Yes, good evening, everyone. How are you all? Everybody is fine? Please confirm whether I'm audible or not. Okay. Thank you, sir. Thank you, Divyesh. Thank you. So let's start the session now. So what we discussed in the last session, can anyone tell me what we discussed in the last session? I want to know that how many of you remember that at what topic we left. Only in short, I want. Okay. So it is already shown in the PPT. Okay. So in last session, what we discussed about the transistor. What is transistor? What is the structure of transistor? How does it work? So I am just going back to this slide. So we understood how does it work, that how the current is flowing in the transistor. So after understanding the working of this transistor, we were able to draw the symbol. So transistors are shown by this symbol, right? We have two transistor NP and PNP. So I will draw the same thing twice first, like this. But the difference is of this arrow. One will be outside, second will be inside, right? So this was N, P, and transistor. So electrons were repelled in this direction, right? And the current direction is opposite to this. Okay. So if electrons are moving in this direction, then current will be in this direction in this. So this IE will be inside. If it is PNP, PNP, then this direction will be inside, that will be I, like that. Why? Because here is N, here it is P. So P means holes will be repelled in this direction, and the direction of current is in the direction of holes. So if holes are moving in this direction, then current will also be in this. So in that case, current will be in. So you can see this direction is outside the transistor, like this, and this is the inside. So it is outside, so it is NPN, and this is inside, this is PN, right? So if you understand the working of this transistor, then you will be able to draw this diagram very easily, because the direction of this current, emitter current, shows here. It is here. Okay. So this direction will always be drawn at emitter terminal. This is emitter, this will also be emitter. Middle will always be base and remaining will be collector, right? So base, emitter, and collector. I hope you understood this thing. Now, what I told you, that in any network, if we talk about any network like this is network. Network means the circuit. So network can work only in if it has four terminals, two for applying input and two for getting output. Right? We will apply input here, we will get output here. So one is main line, second is ground line. One is main line, second is ground. So ground line is this. This is the negative line. Okay. So one, two, three, and four lines are required. But we have made two and four common, right? So how many lines are required? One, two, and three. three lines means three terminals are required, in which this terminal and this terminal should be common. So similarly, in case of transistor, we have emitter, base, and collector. So if we use emitter here, it will be emitter, it will also be emitter. Then this configuration will be known as CE configuration. This one. If we use base, so it will be base, it will also be base. Okay, so it will be known as common base configuration. This one. And if we use collector, so this will be collector, this will also be collector. So whole line from here to here, it will be collector, so it will be known as common collector configuration. So how we are making the terminal common, and which will be used for input, this one and this, which one will be this. So I told you two things, that base will always be input and collector will always be output, until unless it is not common. So if we talk about common emitter, so neither base is common nor collector. So base will be input, collector will be output. I am just writing here with another pen. So I am writing here input and output, right? So in common emitter, base will be input, collector will be output. But in this case, base is common now. So this condition will not be followed, but this will be followed. So in any of the cases, either two or at least one will be fulfilled. So in common base, first condition is not fulfilled, but second is, so we will write collector as output. Base is already used here, collector is here, then remaining will be emitter, it will be used for input. Okay, so emitter will be input line for common base. In common collector, this is not fulfilled because it is common now, but it will be fulfilled. So base will be input, so we will write B in case of input. Collector is already used here, emitter is left, so emitter will be output. So if you remember these two lines, then this thing, input and output, means selection of input and output line will be very easy for you. Okay, so use carefully, right? In case of common emitter, what is this? Base and collector are, base is input, collector is output. Got it? So if we talk about the common base configuration, this is the first configuration. So what will happen? We have used transistor here because base, we have to make base common. That is why we have drawn like this. In every case we will use like this, but in case of common base, because base is here, so we have to ground this line, so we need to just rotate it. Okay, so base is grounded, it is grounded here. Now which win, it will be input line, it will be output line. So which line will be input and output, you should go back. So in common base, emitter should be input, collector should be output. So you can see here that input is here, this is for input, and collector is here, that is for output. Emitter is used for input, collector for output. So that selection is useful here. Got it? We have used NPN. So N means in case of N, that will be outside. So current is outside here, you can see it. And this arrow is always drawn at emitter terminal. So it is there. Now the battery. So this emitter base junction should be forward bias, right? Or collector base junction should be reverse bias. So to make emitter base junction forward bias, so N is type of, means emitter is type of N, and it should be connected with negative. So you can see that this is negative, this is positive, this is negative, this is right. So this battery is making this junction forward bias. So this is forward bias. And to make this junction reverse bias collector base, so collector is of n type again, so it should be connected with positive. So this positive terminal of VCC will make this junction reverse bias. Got it? I hope you understood. Now you can write. I am just using another pen. The arrow is here, so emitter current will be this. Positive is here, so current will flow in this direction. So IC will be this. IB, because the current will flow in this direction, so IB will be in this direction, right? Now the voltage. So this is E line, this is B line. This is C line, this is B line. Okay. So voltage is nothing but the potential difference. So difference is always, suppose we want to write distance between A to B. So what we will write? We are using D for distance AB. So what it will show? This is the distance between A and B, right? A to B distance is denoted by DAB. So similarly, we want to write voltage between emitter and base. So what we will write? We will write VEB. Again, we want to write voltage between collector and base. So it will be, so it is written here. VCB is here, VEB is here, right? So this is the voltage shown between emitter and base. Clear? And this battery, it is connected with emitter, so it is VEE. It is connected with collector, it will be VCC. So these are the batteries which will make the transistor in active mode. In active mode, what should be there? Emitter base junction should be forward bias, collector base junction should be reverse bias. So these batteries are making this transistor in active mode. Have you all understood the working of this transistor, how it is drawn? Because we should know each and everything. Now, after, if you understood this thing easily or properly, then remaining can be drawn by you very easily. Just a minute. So have you all understood how we have drawn this circuit diagram and what is the meaning of VEB, VCB, why these batteries are connected like this, right? Anything that you want to ask, you can. Have you understood or not? Nobody will give the answer or reply at least, whether understood or not. Okay, Bhumen, I am just explaining again. No, don't worry. But a little bit fast, right? In in common base configuration, what will happen? I told you these two things, right? Depending upon these two, we have written these things. It is very important. If you understood this, just a minute. Okay, so if you understood this thing, then it is very easy for you. So what will happen? Base will be input, I am writing here, and collector will be output. So in case of common emitter, both will be satisfied. Base will be input, collector will be output because emitter is common. In case of base common, that is CB, so it will not be, I am writing as CB, CC and CE, right? In CE, both are satisfied, but in case of CB, it is not satisfied because base will not be input because it is common. So this will be satisfied. So output will be collector. So we return here, right? So base is common, collector is output, then emitter will be remaining. One will be remaining, that is emitter. So obviously emitter will be input terminal. In case of common collector, so it will not be satisfied because C is now common, but base will be satisfied, so we will take care. So we will write B here, and collector and base are used. Emitter is left, so emitter will be output. Right? So this is the circuit diagram. I am just removing because you need to see again. Right. So this is base. So we have to ground this. That is why we have just rotated so that this baseline can be grounded. So this is baseline and it is grounded. Okay. Now which will be input and output? We will go to this, right? So for base, input will be emitter, collector will be output. Okay. So emitter is here, that will be input because this is input line. This is output line. Okay. So this is input line. So this arrow is outside. It means current will flow because this is positive, this is negative. So current will flow in this direction. So IE will be in this direction. And this is positive, this is negative. So current will flow in this direction. So IC will be in this direction. And IV will be in this because current is this direction. But why we have used these batteries like this? So these batteries are actually making the transistor in active mode. So what active mode says that emitter base junction should be forward bias. So emitter base junction should be forward bias means this emitter is of N type. This emitter is of N type and N should be connected with negative, right? So this is making forward bias, and this N type collector is connected with positive. So this battery will make this junction reverse bias. So this is reverse bias, this is forward bias. Got it? Now this voltage. So I was just talking about this voltage, this and this. So this voltage is between emitter and base. This voltage is between collector and base. So how we can write? VEB will be between emitter base, VCB will be between collector and base, right? So I explained all about the transistor circuit diagram. Okay. Have you understood now? Okay, thank you. No problem. Now these are the uh, summary. You can say that it is base is common between emitter and collector. We have already understood. Mainly used for collector emitter and voltage, it is okay. Very low input impedance, this is important. And very high output impedance, this is very important, because whenever we use any component in any mode, then what is the impact of impedance at input and output side, it is more important. Okay, so somewhere we want low input, somewhere we want high output, right? High input, low output. So accordingly, this circuit provides low input impedance and high output impedance. So we have to remember, whenever we need input low and output high, then we should prefer common base configuration. Now the characteristics. So characteristics means there will be input characteristics. This is actually graph. There are separate characteristics for input as well as output. So for input characteristics, for input characteristics and output, I will, which versus which we will draw, and which will be constant. So input characteristics will be drawn between input voltage versus input current versus input voltage. Okay, what will be input and current input voltage, we will see here. Similarly, for output characteristics, it will be output current versus output voltage. Both will be input, both will be output, but the constant value in case of input will be output voltage. Means we have to constant the output voltage at any value, and we will vary the input value. Accordingly, we will get this graph. In case of output characteristics, it should be input current, right? So we have to remember this thing. For input characteristics, we will constant the value of output voltage. For output characteristics, we will constant the value of input current. Now we will replace this I and O according to the configuration. In case of common base configuration, what will be, this is common thing. It is for all configurations. Okay. So remember it. I will ask in next configuration. Okay. For input characteristics, which versus which and which will be constant. I will ask you. Okay. So it is common for all three configurations. We have to just replace I and O, that is output and input. What will be input, what will be output? So in case of common base configuration, input current will be, this is ammeter, input will be applied at this. So input current will be IE and input voltage will be VEB. This, whenever we draw the output characteristics, so it will be IC and output current, output voltage will be VCB. Okay. And what will be the input current? That is IE, because emitter terminal is used as input terminal, right? Emitter terminal is used as input. So current which will be flown through an emitter terminal will be IE. So IE is II and V will be VI. So we will replace this VI by IE and VI. Okay. Got it? So you can see here that this is IE whenever we draw the characteristics like this. So this is x-axis, this is y-axis. So at x-axis we consider voltage, at y-axis we consider current. This is fixed. Okay. So voltage will be VEB, you can see here. Current will be IE, you can see here. Clear? This is milliampere. So you have already calculated the current and everything. So what is milliampere? Milliampere means it is, suppose I am writing 2 ampere and 2 milliampere. So what is the difference? 2 ampere is 2 ampere, it is okay. But 2 milliampere is 2 into 10 power minus 3 ampere. Minus 3 ampere means 0.002 ampere. So it is very less value, right? Okay. So this is the difference between ampere and milliampere. Now in characteristics, what we are doing? We have constant the value of output voltage, that is VCB. So V out will be VCB. VCB will be V out here. So we have written VCB here at 2 voltage. So it is fixed. We will not change it. We will change only VEB. So we are applying constantly. We are moving in this direction for voltage. Current will move in this direction. So we have applied, suppose, 1 volt. So this is I is 0 here. Again this, again 0. But after reaching this point, it is now this value. So this is value, this is the value. After reaching at this, so you can see here for 2 milliampere, after this voltage, it was rising. Till this point, it was current was 0, right? Till this point, the voltage is 0. We increase this, and got the value of current, and we drawn this characteristics. But after increasing the output voltage, that is 5 volt, we have seen that this current is 0, so it is reduced. Means for less value of voltage, we are getting out current value. Okay. Again, we increase the voltage value, output voltage. This was again decreased. So in case of common base characteristics, higher output voltage will give the current at lower voltage value. Okay. At less value of VEB, we got value of IE. In this case, it was 0 at this point. In this case, it was 0 till this point. In this case, it is only till this point. So it is continuously decreasing. If we draw for 9 or 10 volt, it will again be like this, like this. Okay. So it will again be reduced. So further, it will continuously decrease the input voltage value, and we will get the input current at less value of voltage. Understood? How do we draw the characteristics? Understood or not? Okay, thank you. This is output characteristics. Now tell me, between which we draw output voltage, output characteristics, and what will be constant. Tell me. I told you that I will ask for output characteristics, between which we draw the characteristics or graph. भाई थोड़ा तो याद रखिए. This is this. So this output characteristic will be drawn between output current, output voltage, while input current will be constant. You you can give the answer by seeing this diagram also. You can see that this is between output voltage, that is this, and output current, that is IC. This. And what we have constant. So whatever is written in this case, this was written at here, at this position, and in this case, it is written. So what is IE? IE is this. E means this, and this is the input current, IE. So what we have done, we have constant the value of input current and varying the output voltage, and we are getting output current. That's all. So what we have written here or remembered here, it is useful here. Got it? So whatever I am drawing like this in box, it is useful for you. It is common for all. For common emitter configuration, common collector configuration, this will be useful. Okay, so I will not tell you these characteristics. You will study yourself. Okay. So what we have done, we have increased the output voltage. First, we have fixed the input volt current at 5 milliampere and start varying voltage, and we will get the current accordingly. So at 0, it is not like that. Practically, it will be like this. So after some voltage, it will start conduction and current will increase. So in this direction, you can see up to this point at right. This current was continuously increasing, but after reaching this point, it is constant. It is constant now. Similarly, increasing this input current 10 milliampere, it was increasing like this, but after reaching at this point, it is again constant. Again, we increase the input current. It was initially increasing, but after this point, it is constant. Okay. So in this case, we will have the fixed output current like this. Okay. This is the gain, that is current gain. So by which symbol we denote this current gain? So this current gain is denoted by common base, that is alpha. Okay, here it is. So what is this? Gain is output upon input, but it is current gain, so we will write output current upon input current. But in this case, common base configuration, you should know what is output current. So output current is IC, input current is I. So alpha is equal to IC upon I. This formula is useful for numerical also. Whenever you are asked to calculate the current gain in common base configuration, and common base configuration may be or may not be given. Okay, so you have to find by seeing the circuit diagram. If I give you this circuit diagram, I have not written anything below this, nothing is here, then you have to understand it is common base, because base is common here, right? And current gain of common base configuration under exact analysis, this is the this is under exact analysis, right? If we write in terms of minority current also, that is known as leakage current, because there is some leakage current also whenever the conduction is there. So IC is there, it is okay, but input current is the addition of the input current itself and minority current, that is known as ICBO, right? ICBO is the current between ICB, the current between collector and base, while third terminal, it says third terminal, that is emitter, is open. So this should be open, means we will disconnect it, and then the current which is flowing is ICB. Okay, so this is this. So what we can write, IC can be written as alpha IE from this, but here is some minority current also, so it will be added with it. ICVO. So IC is nothing but alpha E using this formula only, but some leakage current will also be there, that is ICVO, that is current between collector base while third terminal is open. Last open is showing that third terminal means which is not here, E is not there, so emitter terminal is open. So we will disconnect it, right, like this. We will just disconnect it. So if it is not, current will not flow. This is known as open. Okay. Any doubt to anyone? Any one of you? Got it? Please reply. Shall we proceed? Okay, friends. Thank you. Now it is common emitter configuration, that is CE. So what will happen? In common emitter, input will be base, output line will be collector line, because both are satisfied here. So what we will do, we will make this emitter grounded, that is common. So common line is always grounded. Base will be used as input, here it is, like this, and collector will be output, that is. How this battery is connected? Base emitter junction should be forward bias, collector base should be reverse bias. So this is NPN. So this base is of P type. P type should be connected with positive. So this is forward bias, satisfied. This collector is of N type and should be connected with positive to make it reverse bias. So it is. So the current will be this. Sorry, IB. This is IE, right? And this is positive, so current will flow in this direction. So it will be IC. If you forget the direction, right? So what you remember this equation, this is transistor equation, transistor current equation. IE will be equal to IB plus IC. So if IB is in this direction, IE is in direction. If you draw like this, IB is in this direction, IE is in the direction. Then using KCL, what should be there? This is equal to this plus this. So it is outgoing current from this node. It is incoming, so it should also be incoming. Why? Because we have to add it. Addition will always be in the same direction. Either it is outgoing or incoming. So if IB is incoming, then IC should also be incoming. So you can see that IC is okay. So you should not do the mistake in the diagram. And this is common emitter base is common between base and collector, as we have already done. It is used for audio signal amplification. So in most of the cases we use common emitter configuration for amplifier. Okay. Input and output impedances are moderate, so it is neither low nor high. It is moderate, and it provides high voltage gain because amplifier is used to amplify the voltage. Okay. So if output voltage is high, because voltage gain is AV, right? we generally, or you can write GV, generally AV we write, output voltage upon input. So if AV is high, then it should also be high, right? Vi is already in low, because in audio signal the voltage is low, so it is already low. Then if we want to increase gain, then we have to increase the voltage, so voltage gain is high in this case. Understood? Good. Now this is the input characteristics. So for input characteristics, we have to draw between input current. Input current is IB versus input voltage, that is V. Because ammeter is common, we are applying between base and ammeter, so VB. And what should be constant? Output voltage. So output voltage is VCE. Okay. So you can see that it is drawn between VBE and IB, while VCE is constant. So in this case, what we are saying that at low output value, the input at low input value, the current is increasing like this. But after increasing the output voltage, it was increased. Again, output increased, then this input voltage is also increased. Okay, right? So output voltage is continuously increasing, but at higher value of VB, the current is increasing. This is like that. And for output characteristics, it will be done between in output current, that is IC, versus output voltage, that is VCE, while input current, that is IB, should be constant. It is constant. So you can see here VCB. It is not VCB, it is VCE, right? And it is IC, right? It is IC. And this IB is constant, so you can see IB is constant. So if you don't understand this case CEC, then everything will be wrong like this. Here it was written VCB, but if you don't know, you will consider this as correct. But if you have the logic or understood properly, then you will say, sir, in place of B, it should be E. How it can be CP? Because if this is E terminal, then it cannot be B, right? So output is between collector and emitter. So it should be VC. So what we have done, we have just fixed the value of IB at 100 microampere and increased this. So at low value of output voltage, the current is increasing, but after some time it is constant. Again it is constant. Again it is constant. But increasing the input current, the higher value of output current we are getting at low voltage. You can see at this value, same value, it is this, it is this, it is. So at the same input value, means output voltage value, the value of current is different. It is in case of IB, I am just writing IB1, IB2, IB3. So it is at IB1, it is at IB2, it is at IB. So you can see at the same voltage value of VCE, we are getting higher value. Okay. if we are increasing input current. Got it? So you should know how to see the graph. Any doubt to anyone? This is again the current gain. So current gain in case of common emitter is denoted by beta. So beta gain is output current. So output current is what? IC upon input current, that is I. It is very easy. Here it is. Okay. Now again same thing. Here IC will be equal to beta IB. You can write here, right? But this case, this is different because this is C, this is E. So this is between I, C, E, but base terminal should be open, so it will be ICEO. In earlier case, it was ICBO because here it was base. Now here it is ammeter, so it is E. Here it was B, right? Any doubt? And last configuration is common collector. So collector is here now. It is grounded. So what will happen? Input will be base, collector will not be output now, so output line will be ammeter. So base is here for input, ammeter is here for output. Again it is NPN transistor, so base is of P type, NPN transistor. So this battery is wrong. Why? Because we have to make it an active mode, forward bias. So this base and okay, it is wrong. And P, so it is of P type. P should be connected with positive, so it should be like this, positive, negative, right? So this positive will make this P forward bias. And for this ammeter is of N type, this. So for N, it should be reverse bias, so it should be, we have to connect this also. So it will be positive, it will be negative. Okay, so this positive will make this emitter, N-type emitter, reverse bias, right? Any doubt? Simply you can understand that current is moving in this direction. It means current should flow in this direction. Earlier it was positive, negative. So current will flow in this direction according to previous one, right? So this current will not be inside, it will be outside. Okay, so you can see that this was wrong. It should be opposite. So it should be verified by you if anything is written wrong, printed wrong. Okay, understood. I think you understood this thing very easily. Now this is input voltage. You can draw this current IB. This is like this, IE, right? So you can, right. Now it is voltage. So voltage is between base and collector. So this is VBC. This is ammeter. This is base. This is collector, sorry. So it will be VEC. Got it? This battery is connected with base, so VBB. This connected with ammeter, this is VEE. If it is connected with collector, then it will be VCC. Simple. Okay. What is the use of this battery? This is battery for biasing of the transistor. Simple. So it is common. We have the low output, high input impedance. Okay. Common collector was, common base was high output, low input. It is opposite. And used in impedance matching circuit. Okay. It is also used in voltage follower. So it is not in your syllabus, otherwise I can explain you. Now the characteristics. So input characteristic between input voltage. So input voltage will input current, that is IB, and input voltage, that will be VBC. Or output voltage should be constant. The output voltage is VEC or VCE. You can write VCE, you can write VCB, whatever. Okay, because here it is VC, that is why I have written here. But it should be VEC, right? So what is there? We are increasing the voltage, but current was zero. But current was zero. After that, it was increasing. It was increasing, right? So this is the input characteristics of common collector configuration. But in this case, you can see that VCE, this is greater than this one. So higher voltage, higher output voltage and input voltage and higher current. Lower input current, input voltage, both. And same thing will be drawn here. That is the output current, that will be IE. Output voltage, that will be VEC. And input current, that is IB, constant. So you can see here, this is output voltage, this is output current, and we are increasing it. Again the same, it is constant. After that it is constant. After that it is constant. But this is out opposite. In earlier case, it was higher, lower, but it is, this is lower, this, this is lower to this. So maximum value is of, lowest is of IP. So I think no need to explain, because we have already explained this in detail in earlier cases. So what we understood in this session, we have understood that what is transistor, what is the use of transistor, right? What which component we replaced? We replaced vacuum tubes. So vacuum tubes were used in place of transistor in earlier years, right? Now we have transistor. How many layers are there in transistor? We have seen here how the current, electric current flows in transistor. What is the use? What is the advancement of electronics? The advancement means we have used a transistor that replaced uh, vacuum tubes. Okay, and vacuum tubes were typical and not were providing the proper output. Now it is made up of, means we have a semiconductor device, so it is providing proper output value in this case. Reliability is good. Speed of operation. Earlier it was providing the output a little bit late. Now it is giving fast output. So its speed is high. Heating is also low because vacuum tubes were means became heated if we are continuously using. Modest cost because cost is also effective in this case because now we are also reducing the amount of cost day by day of electronic items. If you purchase anything 5 years back, now it is very cheap. So these were superseded in the 1960s and 70s by ICs. Now we are not means we are using, but if most more number of transistors are being used, then we have ICs. So in ICs we have large number of transistors on single chip that is used in computers and many devices. Okay, and performance of transistor is an amplification, so it is basically used for amplifiers, not for switching. Okay, so these are the keywords that we have used: emitter, base, collector. What are the reason? What is the doping we understood? So these are the learning outcomes. We have understood the transistor, what are the modes of operation: active, saturation, and cutoff. Also explain the characteristics and current components of transistor, means holes and electrons both are current components. What is alpha, beta, gamma? Alpha, beta, gamma are the current gains. Alpha in case of common base, beta in case of common emitter, and gamma in case of common collector configuration. And also explain all the configuration in detail, right? So this was all about the session. If you have any doubt, you can ask me. Any doubt to anyone? Should I share again? I think it was automatically unshared after completion of the session. Okay. So I hope you all have understood all the things that we discussed today, and we will discuss the next topic in next session. Okay, so thank you so much. Happy learning. If you don't have any doubt, you can leave and join the next session. Thank you, woman. Thank you, thank you.